YouTube, my name is Cherokee Portman. I'm here to instruct you guys on exactly what are waves. Now, I'm not talking waves, you grab your board, you go to the beach and get stoked with a couple friends. No, I'm talking about waves in the universe, like electromagnetic waves. And one of the ways we look at these waves is on the electromagnetic spectrum, which is basically like a bar graph. Starting on this end, you've got like radio waves, all the way down UV, visible light, microwaves, all the way up into gamma rays. Now we'll start by talking about what these waves are. Radio waves, first off, are made by types of a transmitter, like an antenna, like a phone tower, and their wavelength tends to vary. They're also given off by stars, sparks, lightning, thunderstorms, etc., etc. Next bar up is microwaves, and they're high-frequency radio waves, and they're emitted by also transmitters or off star energy, and are found everywhere in the universe. Now, infrared are just below visible light in the spectrum. Basically, we can almost just see them. And infra, basically, the prefix, infra, means below. And they're given off by stars, lamps, flames, and anything else that's warm. They're given off by heat, essentially. So stars are a hot spot. Visible light waves, which is like white light, coming out of this light here, we can see it. It helps and goes to our cornea and helps us see objects, see in 3 dimensions. It's how we see, and it's what the only wave we can see. UV light is given off by special UV lamps. It's used in, like we're talking about waves doing repair surfboards, given off by stars, black holes, and even some magnetars, I believe, which are highly magnetic stars. And X-rays are next up on the spectrum. Like you go to get a doctor, you break your arm, and they X-ray. They're given off by a lot of stars, stellar nebulas, and X-ray machines fire concentrated beams of X-rays through you so they can see through you. Now, the last one up on the spectrum is gamma rays. Gamma rays are extremely dangerous. Those are what you get in radiation, alpha and beta particles, and they tend to be extremely hard to stop. You need a couple feet of concrete, a couple feet of even lead sometimes to stop them in the event of a nuclear explosion or any sort of radiation fallout. Gamma rays are highly deadly and will cook you. It's very dangerous. Now, why study waves? Well, you see, waves, in essence, are mediums for energy and essentially information to travel through the universe. Like, I'm talking to you now, and sound travels through air as a medium. Well, energy and information needs a medium to travel through, but there's not always air for that to travel through. So radio waves, microwaves, infrared, all the stuff on the electromagnetic spectrum is basically its own medium to travel through. The actual wavelength is its own medium. That way, we can pick up on all these UV rays from stars and clusters billions of years in the past, because the light's so slow, it takes that long to get here, and we can see all this stuff. Now, waves in general tend to focus primarily on, what isn't visible, because we can only see a small portion of these waves, and they're found everywhere in the universe. Now, why study these waves? Well, studying these waves gave us television, radio, UV light. It's for tanning booths, so everybody can go out and get fake tans, right? So, that's waves in general, really short, really brief, what they are, what the electromagnetic spectrum is, and what they're used for. Thanks.